Hello everyone, today is Thursday, March 30th. I want to make sure that you have today's notes in front of you that say Lesson 9.1, Simplifying Square Roots. Also want to remind you that after you are finished with today's notes, that you are to take out your extra credit which was given yesterday and work on. If you need an extra copy, there are extra copies in the back to the left in the little wooden file holder. Okay, all right, today's lesson is a little bit of a supplemental lesson. We kind of talked about this a couple days ago when we did our little Easter egg activity. And what we're going to be doing is we're going to work on simplifying square roots, okay? So we're going to be simplifying our non-perfect squares. If you realize, we've been dealing with a lot of equations that end up having square roots in them, right? Because we've been working on taking the square root of numbers. So what we're going to do is we're now not just going to leave the numbers under the radical. We're going to see if we can simplify the numbers that are under the radical. So today's lesson is how to do that. And I know that you were taught in 8th grade. So at the very top of your paper, I just want you to record your perfect squares. So like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, all the way up to 20 squared. Okay? Those are your perfect squares. They're going to be very important numbers that we need to make sure that we have a list of. Alright, so when we start to simplify our radicals, we're going to think in terms of perfect squares. Okay, we're going to think in terms of these numbers that you just wrote down at the very top of your paper. Alright, good. So if you didn't get the rest of them, just copy off of a neighbor. Okay, or we can always flip back to the screen if needed. So, to simplify a non-perfect square, what we're going to do is we're going to look for the largest perfect square that can be divided out of the number under the radical. Okay? We know that non-perfect squares are irrational. So they're numbers that go on and on forever. So you're not going to actually write the decimal version of them. Okay. So I'm going to take the square root of 12, for example. Okay. Before we used to just leave it as a square root of 12. Do nothing about it. But there is a perfect square that can be divided out of 12. Okay. What is the largest perfect square that can be divided out of 12? Okay, so you go back to your list, and you look at all of the numbers here, and what we find is 4. So 4 times what is 12? 4 times 3. Okay. Now when you do this, you're always going to put your perfect square first. Always going to write that in the beginning. Now, what is the square root of 4? 2 with a radical 3 left over. So that would be the square root of 12 simplified, okay? Because we divided out the largest perfect square, and that's what gets it in front. Okay, if you look at the bottom examples, okay, that are actually written on your paper. So the square root of 20 is 4 and 5. And then the square root of 48 would be 16 times 3, okay? What we did was we actually took the square root of 16, which was 4, and that came on the outside. The hardest thing is going to be determining if there is a perfect square that can be divided out. So if we look at 75, think about the largest perfect square that can be divided out of 25. Good. It is 25 and 3. Put the perfect square first. The square root of 25 is 5 with radical 3 left over. Okay, next one, square root of 8. What goes into 8? Can't be 8 and 1, it has to be a perfect square. The largest perfect square is 4 times 2. Perfect square goes on the left side. So the square root of 4 is 2 with radical 2 left over. Okay? The square root of 4 is 2 comes out of the radical sign, and we just bring down what would be left over. Okay? So now you're going to flip your paper over. What you're going to do is you're going to work on 3 through 10. Okay? Be careful on number 8 because number 8 is a perfect square.